In this first video, what we want to do is we want to go over some of the basic concepts that you may have already seen in a previous math course. The first one that we want to start off with is the order of operations. So some of you may have heard this as PEMDAS before. So being able to simplify an expression using the correct order of operations. So let's look at an example here, see if we can remember how to simplify. So in our first example, we've got 5 plus 2x parentheses 3x minus 1 plus 7x minus 42. So using our order of operations, the first thing that we're going to look at is for parentheses. So I look at these parentheses. Inside the parentheses, there's nothing to be done. So we'll move on to exponents. There's no exponents, so I don't need to do anything there. The next thing I'm going to look at for is multiplication and division. Those could happen in either order. So if I see multiplication, I could do that, or if I see division, I could do that. Okay, so in this case, I do see multiplication. This kind of multiplication is actually going to look like something we call distribution. So I'll make a little note here. So when I distribute something, what that means is I'm going to multiply everything on the outside of the parentheses to everything inside the parentheses. So what that's going to look like is I'm going to take 2x and I'm going to multiply it by 3x, which will give me 6x squared. Then I'm going to multiply that 2x by my negative 1, which is going to give me negative 2x. All right, so I've done all of the multiplication. There's no division, so I'm going to just write down the rest of my expression. All right. I'm going to move to the next operation in PEMDAS, which is adding and subtracting. Now, it doesn't matter if I do the adding first or the subtracting first, but what that sometimes will look like, another thing to kind of think about it as, is combining like terms. Okay, so that's something that we talk about, is combining like terms when we talk about addition. I say that because if I look at this 5, it's going to actually be combined with this negative 42. So I can think about it as 5 plus a negative 42 or 5 minus 42. Either way we do that, we're going to end up with a negative 37. Right? So then we look and see if there's anything else that we could add or subtract or combine like terms with. And I see a negative 2x and a positive 7x. So combining those together, either as negative 2x plus 7x or 7x minus 2x, doesn't matter. I'm going to end up with a positive 5x. And then I see that I have this 6x squared, but there's nothing that's a like term, so I'm just going to leave that there. If I want it written in standard form just means from the highest exponent down, so it would be 6x squared plus 5x minus 37. And that would be our simplified form using PEMDAS. Okay, so if you want to, you can work on this next one. We've got 4 minus 3 parentheses 2x plus 4 plus 3x parentheses plus x plus 1. All right, so if you want to pause the video for a minute and try that one, and then I'll come back with the answer. So hopefully you gave that a try. I'm going to walk through this. I would first look inside my parentheses for that PEMDAS. So I'm looking inside parentheses. And inside that parentheses, I notice I have a 2x and a 3x that I can combine. So I'm going to have a 5x plus 4 inside the parentheses. The next thing I'm going to look for would be my exponents. I don't have any exponents. Then I'm going to look for multiplication. Again, I see distribution. So I'm going to distribute that negative 3x. So I'm going to have negative 15x minus 12. I'm going to leave that 4, that x, and that 1. All right, so then I say, okay, well, what else can be done? We can now add or subtract, which means I can combine those like terms. So I'm going to combine my 4 minus my 12 plus my 1 is going to give me a negative 7. And then I'm going to combine my negative 15 and my x, which is going to give me a negative 14x. And that would be my answer in simplest form. So this hopefully reviews you on that order of operations to help us simplify an expression.